Okay, now that we know what a perfect square is, we are going to finish off our factoring unit by talking about the difference of two squares. This is kind of a special case. So that's our learning target. So how do we factor the difference of two squares? Well, as you might recall from distribution, when we have, let's say, two binomials, x plus 6 times x plus 6, we would distribute, right? We'd get x times x is x squared. Then we'd go x times 6 is 6x. And then we would say 6 times x is 6x. And then we'd say 6 times 6 is 36. And then we would combine like terms. So these two terms in the middle here, 6x plus 6x, they combine to be 12x. So we'd end up with x squared plus 12x plus 36. Now, that made sense too when we went backwards and went back to this way. We said two numbers that multiply to be 36, but add up to be 12. Well, that's 6 and 6, so that's why you see this 6 and this 6 here. So it all works out and all makes sense based on what we've talked about. Okay, so now let's talk a little bit about what happens if we have the 6 and the 6 again, but now one of them is positive and one of them is negative. All right, so let's distribute this out. X times x is x squared. X times negative 6 would be negative 6x. Now we're going to do 6 times both of these, right? So we would have 6 times x is 6x. And 6 times negative 6 is negative 36. Well, now when we combine these like terms in the middle, you'll notice they cancel out. Negative 6x plus 6x is 0x, or 0. So I'm left with x squared minus 36. There's no middle term. This is a special case. Also, this is a perfect square, right? And so is this. And again, that's because 6 times 6. And this is x times x. So if we go backwards, you'll notice that if I go from here to here, I can take the square root of x squared. Square root of x squared is x. I could take the square root of 36, and that's 6. And then if I just write one's positive and one's negative, that's how I could get there. So that's a lot of information, but this x squared minus 36 is my difference of two squares. It's called a difference because there's subtraction, and it's called two squares because this is a perfect square and so is this. There's two of them. So difference of two squares. The name makes sense. So we're going to learn today how do we go back here from that factored or from that difference of two squares to the factored form. Okay. So first of all, let's talk about perfect squares. Let's refresh our memory on perfect squares. The first thing you want to recall, we discussed this last time, is if you see numbers, they are going to be these ones on your multiplication chart right down the middle, right? 1, 4, 9, 16, 25, etc., all the way up. I mean, it keeps going, but on our chart here up to 225. So if it's any one of those numbers there that's highlighted in the gray, down the diagonal there, like 49, that's a perfect square, okay? Variables, you're going to see variables, and if they are raised to an exponent, as long as that is even, it's a perfect square. So if it's even, you're good, okay? If not, no good. So if it's x to the 7th power, nope, not going to work. Now, if you see both, like let's say you have 100x to the 12th power, you'd say this part, the number, and the variable part have to both be perfect squares. So 100 is a perfect square, yep. And x to the 12th, it has an even exponent, so we're good. If either of these parts is not a perfect square, then it won't work. Then it's not a perfect square. Okay, so that's a quick refresher on that. Now, difference of two squares, here's what you need to know. What does it look like? Well, we kind of already talked about that before. We saw one, x squared minus 36. There are two terms, okay? So that's important, two terms. They are being subtracted, okay? And then both terms are perfect squares, okay? So those are the things that you really need to know. It's going to look like this, okay? Now, you might see the square there, or that could be something else, or it might be not there. So you have to figure out what that is. And how do you figure that out? You take the square root of each term. That's your A and the B. And then you're going to write one with a plus sign in front and one with a minus sign. Now, if that doesn't make any sense, that's okay. That's why we're going through this. All right, so here's how we do this. Okay, now I have the directions on the right. It says, or the things to reference on the right, but the directions are determine whether each expression is the difference of two squares. If so, you need to factor it. If not, you're going to write no. Okay, so first of all, are there two terms? Yes, I see two terms here. We're good. Okay, are they being subtracted? Yes. Okay, so we're good. Are these both perfect squares? Well, x squared has an even exponent, so yes. And 16 is a perfect square, so we're good. All right, so now we're going to look right here at this bottom part. Okay, difference of two squares. Now, we're going to find the square root of each term. Okay, so the square root of x squared is x. What's the square root of 16? 4. Okay, this is like your A and your B now. Okay, and it says you're going to write A plus B and then A minus B. So if they are, everything has checked out so far, then we're going to write x plus 4, x minus 4. Now this is the factored form of this. This is the difference of two squares, factored form, and that's how we do it. Okay? And that's it. Okay? Now they can make this a little bit more complicated, but if you're savvy enough, you'll be fine. Okay, so first, always do with the checklist here that you see right here. Start with that. If you see any of the answers to that checklist are no, then you're done. You're going to write no. Okay, so are there two terms? Yup. Are they being subtracted? Yup. All right, are they both perfect squares? Well, let's see. Is 8 a perfect square? No, it's not. P squared is good. The 9 is good, q to the 4th is good, but the 8 is not. So if any part of these is not, you're going to put no. You're done. You can't. It's not a perfect square. So this is no. I can't factor that. So you're going to have to be careful. They're going to try to trick you a number of times, so be ready for that. Okay. So same directions. Here we go. Let's try another one. All right. Are there two terms? On part C, yes. I'm going to switch colors here. Okay. Are they being subtracted? Yeah, we're good. Okay. And then are they both perfect squares? Let's see. 100, yep. X to the second, even power. 64 is a perfect square. And y to the 6th is even. So yes. So now I'm going to take the square root of this. What is the square root of that? It would be 10x. Okay. What is the square root of this? It would be 8y to the 3rd. Okay, so those are my A and B. So now remember, you're going to write it like this. So A plus B and then A minus B. So we're going to write 10x plus 8y to the 3rd times 10x minus 8y to the 3rd. Now, if you multiplied this out, you would get this back. Okay, so that's my answer right there. All right. Now, let's keep going here. All right. Again, are there two terms in part D? 1, 2, yes. Is it being subtracted? Yes. Okay. Are they both perfect squares? Well, let's see. 16, yep, that's good. X squared, yep, even exponent. 4, yes. Y to the 5th, is that an even exponent? No, that's odd. So nope, this isn't going to work. So I'm just going to write no. Okay, so always go through that checklist first. Okay, part E. Are there two terms? No, there's 3. So this is not a difference of two squares. So right off the bat, that's a no. So be aware, follow your checklist. All right, a couple more, and then I think hopefully you're good. Let's see. Are there two terms? Yes. Okay. Are they being subtracted? No. So in this particular case, it's not subtraction, so this is an easy one to miss. If you missed that, this is a perfect square and so is this. So if you went through and tried to factor this, you would have got it wrong. It has to be subtraction. It's called difference. Difference means subtraction. So this is a no. This is a sneaky one. So be ready for those kinds of situations. All right. Okay, let's try our last one here, part G. All right, so are there two terms? Yeah. Are we subtracting? Yes. Are they both perfect squares? Well, let's see. This is a variable raised to an even exponent, so we're okay there. 25 is a perfect square, and this is a variable raised to an even exponent. Okay, so we're good. So now take the square root of both terms. Well, the square root of x to the fourth is x squared. The square root of 25y to the 10th is 5y to the 5th. Okay, and then now I'm going to write x squared plus 5y to the 5th, x squared minus 5y to the 5th. And there we go. That is factored form. Okay, so you're going to have some that are no's there. Be careful. Take your time. Maybe try one more. I'm just going to do one more here in case we're a little off. Okay, so now this one is two terms. It's subtraction. Now let's see if they're perfect squares, right? 36 is a perfect square. X to the fourth is a perfect square. 121 is a perfect square. Y to the eighth, an even exponent. Okay, so now I'm going to take the square root of this. That would be 6, right? And then to get this part right, you're just going to cut this in half. So this would be x to the second. And then what is the square root of this? It would be 11. And then y to the fourth. If you're not good at these numbers, use your multiplication chart and look on that. And then you just go 6x squared plus 11y to the fourth and 6x squared minus 11y to the fourth. And there we go. Okay. I hope this makes sense. That is the difference of two squares. You want to write this into your planner, and once you get done, check it off once you've submitted to Schoology. All right.